It's another Monday here with teacher Jenny. Join me for another topic. And this time we're talking about continuity of a function at an interval using graphical approach. So let's try to check on the graph here if this is continuous at p at an interval -6, -3. So if you are given an interval and you wanted to check if the function there is continuous within that interval, you have to really consider what type of interval are we having here, whether we're having a closed interval, an open interval, or a half close, half open interval. So here we have a closed interval. This is our symbol for the closed interval, which means that we include -6, the number here indicated, and also the -3, the number indicated as well. Those are included or part of the graph. Now, checking whether the function is continuous on that particular interval, we have to locate our x, which is -6. So this is where our x -6 is. And locate our -3 on x. This is where -3 is on x. And we are to consider the type of interval there. That's a closed interval, which means that this one here is included. This one also is included. So we are to trace the graph. And so with this other value here, we are to trace the graph. And we will be concentrating on this particular portion of the graph because that is where our interval from -6 to -3 is. So checking on that one, we are to look at holes or breaks if there is, because if there is holes or breaks within that particular graph, that means that is discontinuous. Now, since on that particular portion, we do not have any gaps, any breaks, any holes in there, automatic, we are to conclude in there that the function is continuous at -6, -3 interval. Now, regardless, whatever will be the look of your function therein, because you might be confused because if you try to look at the entire graph of the function here, you will see a break or gap in there. We really don't care about that one. What we only care is what is within that graph in that particular interval. Let's now move on to another interval here. We have our open interval, which means that the numbers indicated here as the values of your x are not included. Meaning to say, whatever may be the look of that graph, which has our x equal to -1 and x equal to 3 is, we really don't care because we do not include that one. So again, checking whether our function is continuous on that particular interval, we are to locate the value of our x here on the graph. We have our x equal to -1. This is where -1 is. And x equal to 3. This is where our x equal to 3 is. Tracing the graph for those particular values, we need to trace the graph as to where the part or the portion of the graph is going to be the focus of our determining whether that's continuous or not. So this is the part of the graph that we will be concentrating on. Now, checking that one, although you can see that these two endpoints here are showing breaks and hole, but again, our interval there is open, meaning it is not included. These 2 points here are not included on the graph because that is open. So which means we are to consider only those that are closer to the -1 here, which is this particular graph until where we are moving very close to our 3, which is this one here. And again, we do not really care about the 3 because this is again open, which means we do not see any breaks at all. We do not see any gaps at all. So that means this is continuous at the interval -1, 3, which is an open interval. Let's try another interval with the same graph here. We have -1 open interval with 2 closed interval. So which means that we have a half closed interval, which is closed on the right side. So which means if this is open, that means to say that we do not look at -1 at all. Although if we try to locate -1 here, this is where we are to trace the graph there because we wanted to look at the boundary of that particular graph as to where we stop and where we begin. We have to really try to slice our graph in there as to what is on your interval indicated as a value. Next, we have the number 2 on x. We have here x as 2. We again trace the graph so that we can see the portion that we wanted to check whether it's continuous or not. The portion there is this one here. Now, checking on that one again, although on -1 we have our hole there and the gap, we really don't care about that one because again of this open interval symbol, which means we do not include -1, which means we are to trace the graph whether we can see any hole or a gap on that particular graph. But since this is without any hole or gap in between, that means this is continuous at the interval -1, 2. So let's try another interval. We have here -1, 1. We have a closed interval, -1, 1 as an open interval, which means that tracing on -1 here, this is x, -1, we trace the graph, and then on 1 here, we also trace the graph. So which means this is the portion of the graph which we are to consider. And then checking on that particular graph, take note our -1 there is with a closed symbol, which means we do include these 2 endpoints here, showing that this one is a hole, this 2 is with a gap or a break. That means this is discontinuous at that particular interval. This is an example of a jump or essential discontinuity. So let's go to another graph. We have this one here, checking on the interval. We have -3 and 2, which is open. So we have -3 here. This is where x -3 is, and x equal to 2 is here. Tracing the graph for those 2 values and checking for any gaps or breaks or hole within that particular graph. Notice we don't have any of that, so which means that this is continuous at -3, 2 interval. Next up, we have our interval 0, 4. So tracing, this is our x, 0, tracing the graph. Our 4 on x is here, tracing the graph as well. Notice that although we have a hole on 4, our 4 here is with open interval symbol, which means that we do not care about this part of the graph. What we only care about is this portion of the graph here. So that means this is continuous because we do not have any hole or break within that graph. Forgive me, this should be 0 and then 4. So let's now move on to another interval. So let's say for that one, is a function continuous still at that particular interval? So again, we try to trace where x is 0, and we need to check what is it. Is it open or closed? This is open. You may have it written like this. This is open, so that you may be guided as well. Or you just have to really trace the graph there and go back and examine whether that is open or closed later on. So tracing the graph, we do not see any problem at all there because we don't have a hole or a break. And then on 4 here, this is problematic because we have a hole on 4. We need to go back. What is it? Is it with an open symbol or a closed symbol of an interval? This is closed, which means we do include this portion of the graph. This is a hole. That means to say that this is discontinuous in this particular example or interval. And that type of discontinuity is a hole or removable discontinuity. So let's go for another graph. Let's try to examine if this is continuous at this interval. So let's try to trace. -5 on x is here on the graph. We can see that we have this graph here, and then we have another number. We have 5. So meaning our interval there is from -5 here up to 5 here. So checking on the graph, if you notice, once we try to trace the graph here, we do not cross this particular portion of the graph where your x is -1. Meaning, within this portion here, there is already a gap in between. Automatic, this calls for a discontinuity. This is infinite or asymptotic discontinuity. Next, let's try to have our other interval. We have here -2, 0. So tracing on x, -2, this is -2. So from this moment on, we move towards where x is 0. This is where 0 is, tracing the graph. Moving from -2 to 0. Is there a hole? Is there a gap? Is there a break on the graph? Tracing that portion, you can see that this is really a gap, which means that this is discontinuous in this particular interval. Another example here, we have -5 to -2. Tracing our interval, we have -5 here and tracing the graph. We have -5 portion here moving towards -2. This is where -2 is. Tracing the graph, this is where our graph that we need to focus on. Is there a break, a hole, or a gap in between? There is none, so that means to say that this is continuous at -5, -2, closed interval. So that is how you identify whether the function is continuous or discontinuous at a particular interval. So again, this is your teacher Jenny saying, always practice, and that will make you perfect someday.